Hey guys, welcome to Bar Z. My name's Stan, and today we're going to go over an industrial air system. It's the receiver tank over my left shoulder, and that's the compressor over my left shoulder. So these are big units, and let's see what it takes to put airlines in a building to accept this kind of volume. And today we're doing some industrial airlines in for a manufacturing plant. And we're just getting set up here. Got my old rigid 535 out. And we burned through an awful lot of material, and I'm going to walk you around and show you the airlines and what we did and how we did it. But let's talk about the hangers, how we're hanging the pipe. We're hanging it on all thread, 3/8 all thread. And we're using what they call a band hanger down here in this bag. It's just called a band or a loop hanger. It's got a little threaded plug in there that threads into the all thread. And then we're using two attachment methods on the building. We've got some little cast iron angle clips that we screw into the purlins, and that's threaded for the all thread. So that's one way we do it. And that's a threaded lag that you can screw right into the purlin. It's got a 5/8 hex on it. Then it's got a 3/8 plug here in the back, and you screw this up into the purlin and then put your all thread right in there. So that's how those are our two different attachment methods. Let's go over the plans real quick, and I've just got cocktail napkin drawings here. This is the building, and our airline system is 85 feet by 78 feet. Everywhere you see a green dot is a 1/2-inch airdrop. Everywhere you see an orange drop is a 1-inch airdrop. Everywhere you see a pink dot is 1.5 inches. So there's more halves. The purples are 3/4. So we got some 3/4 in there. And everywhere you see one of these triangles are isolation valves for the main system. The system is a loop. It does a big loop, plus it has a crossover in the middle. So anywhere over here in this crossover, so we got valve, 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 so we can isolate any section of the building. Valve, 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 and we can isolate any section of the building. So we can cut off this side of the loop, this side of the loop, or the center section of the loop, and work on it. So let's go take a look at the rest of the building. Okay, camera focused. And up there you'll see our attachment methods. I can actually zoom in on that a little bit and let you see that's a SAMI going into the bottom of a purlin with a piece of threaded rod coming down to a band hanger. And that is a Schedule 40 2-inch galvanized pipe. And if you'll notice, all my T's are facing up. And I'll walk this line here. This is a paint mixing room that's going in underneath here. There's one of the big isolation valves. But we got a paint mixing room going in here. And see, we're just barely made it underneath that purlin there. And see, every one of these drops, I'm pointing them up. And we're going to give you an overview of the system here in a little while. There's another isolation valve. More drops. And all these drops are going back to the walls. I'm going to bring you back and show you what it looks like when we're all finished up. But all those airdrops go over to the wall on unistrut, and they're going to come down the wall, and there'll be a ball valve down low. All right, so we hook a turn here, and see, there's just a general purpose drop. We've got a valve already in, but we got a little gooseneck on each one. 6-inch nipple facing up. Same thing there. And we put a air outlet at every 21 feet, because that's what our pipe comes in, unless they specify any different. There's another airdrop there and another isolation valve. I'll zoom in real quick. So you see, we face all our T's up. This allows dirt and things like that to land in the main line, and they can't get out to the airdrop if there's any debris in there. Now, we've got one drop facing down. See right there? That's going to go over to this wall. And this is the location of the air compressors. So we're going to have an air compressor and a receiver tank over there in this area. And we'll have a riser going up that wall, and then we're going to be coming across and feeding that one T that's facing down. And the entire system is pitched, and I'm going to do an overview of the whole thing here in a little bit. There's another isolation valve. There's another isolation valve and another drop up there. And this building was a mess when we came here. They got pipes running diagonally through the building. And then look at that mess over there. That looks horrible. This is a new tenant moving in here, but the old tenant just hacked this place. Nothing's straight. Everything's crooked around here. And then we've got some more drops down this wall. Same thing, T's facing up. But I'm going to back you up here real quick and try to show you the whole building and explain what's happening here without the sun blowing us out too much. Now what's happening is over right here is where we're dropping in and going off to the wall for our air compressors. We've pitched our entire system. All the way along that back wall over there, that's running level. This line running down this wall, the line running down the center here, and that far one way over there, those all pitch down as coming towards me right now. It's not much, you know, we only pitched it 3 inches over probably about 85 feet, but it does drain this way. So when we, over where we're doing our riser, where we feed the system, we're gonna have a drain valve. So when we drain the house lines, everything comes back this direction, and we put a drip leg in to catch all the junk. I mean, it could be water, it could be oil, if the compressor fails. It could be oil, it could be rust. It could be a number of things that can get into an airline. You'd be surprised what gets in there. But we just thought we'd show you our methods on how we install airlines and double loop systems. We've got a very high demand way back here in this corner over here. There's sandblasting cabinets and things like that over there. So with the loop system and a crossover, we've got multiple paths back to the sandblast back over there in that corner over there. And over here, we've got a paint department that's going over here, so they'll be spraying and spray guns. And back here, there's in that paint mixing room, they're doing paint dispensing and pumping. So they're going to have Graco pumps and things like that back there, and lots of spraying going on over here. So they need clean, dry air here. They need clean, dry air everywhere. Sandblasting too. All right, let's go take a look at their air compressor. So this thing's a monster. This is their receiver tank. It's laying down right now, but this is a vertical tank. And it's all from Kaiser. Nice stuff. That's the top of it. She's a big one. There's your sandblast cabinet. There's a blast cabinet there. Dust collector and hopper, elevator, blast pot. Nice little blast pot right there. And then their compressor, they got a really nice one. They got the SCF 75. So this is a monster, and it's quiet. 68 decibels, if you can believe that, for this compressor. Nice touchscreen control panel, or not touchscreen, but a membrane pad. Nice, beautiful unit. And this has got the built-in refrigerated air dryer into it. And there's the one of the after coolers right here. A big radiator. So what a beautiful machine. Anyways, we'll get some video of this after it's installed. I'll let you guys see what this looks like after this is put in, and after our airdrops are put in, we'll do another video and show you what everything looks like installed. So I just thought I'd show you. This is day 3 for us. We've already got all those lines put in the building. And but we'll bring you back after another couple days after we've got some drops in, and hopefully the compressor stuff's got put in, and we can take a look at some of that too. All right. So we're Just finishing up with the pressure test, thank you. And all we did there was put a bushing in there and a hose and hooked it up to a little pancake compressor and charged the line. It took a while, it took about an hour to bring this line up to 125 psi. So this is where the new compressor is going to be going in. That receiver tank, that's the elevation of the receiver tank. It's about 120 inches off the finished floor. And then we put a nice big drip leg in here. And that's going to be a drain, any junk or whatever. We've already got a little bit of junk out of there just from the little pancake compressor. So that's that. And so for the rest of it, the only T in the entire building that's facing down is that one right there. And we've got isolation valves for the main loop system. There's a valve trio there. There's 3 valves on that T section. So we can cut off north side, middle, and south side of the building. And we put drops in just for general purpose, every pipe break. And these drops are finished. These come down to a 9-foot elevation. There's some equipment going in that's going to be 8 foot tall. So a little pipe nipple, and then you're up on top of the equipment. And that occurs in a few places. Another one there. Okay, this is where they're building all their rooms. This is going to be a paint mixing room here. So we got 4 equally spaced down the wall. These are just at eye level. These are 5 foot off the finished floor. So they'll probably come down, do some manifolding and some regulators and some dryers and things like that inside the mixing room or paint kitchen. It's where they actually do their paint dispensing. And then over here they got a kind of a wash tank room. This is where they're going to be doing some washing. So they're going to have some acid tanks and stuff like that in there. And I think they need air for the agitators. So they've got 4 air connections in there. And then another isolation valve. And that's going to isolate the sandblast room. So we've got some pretty big piping here. These are 1.5-inch drops here. So this is a pretty big dog here. And these are all 1 inch here in the center. And another 1.5 inches over here. So this is another sandblast room. It doesn't matter what size pipe you run. You still do the up and over gooseneck riser trick up there. All right. So what we've done is in this side of the line is the kind of the end of the line. And this run that you're looking at right here is dead level. But when you go over to the other side of the building over there at the far end, actually where the pipe is or where the pipe enters the air compressor, which is over there, way over there by that orange bucket, that's 3 inches lower. The main line is put in at a slight skew. You can't see it over that long run, but it's 3 inches lower, and we've got the T facing down. Any debris that gets in the main line, we drain back at that riser that I just got done showing you, and everything drains back to that point. And just park a bucket underneath that drain valve and open her up and let her fly. If you have a malfunction, see, we're not expecting water and oil and things like that to get in the line. That's not an everyday occurrence, but things happen. A refrigerated air dryer, someone forgets to turn it on, someone unplugs it and forgets to plug it back in, or it fails in any other way and they accidentally run for 8 or 10 hours without a dryer, this line's going to fill up and you're going to get water and all kinds of debris up in that line. And if I don't give them a way to get it out and drain it out of here properly, they're going to want to put me up against a wall and shoot me. So that's the reason for the oddly shaped piping. You know, the way the pipe pitches and the way we do the goosenecks. We put a little 6-inch riser in there and let each one do a gooseneck on the way down to the drop. Just keep any debris you have up in that main line and keep it from getting down into the drop and down to the point of use. And in case you're wondering how you make up the modern joints, I use just Teflon tape on anything 3/4 inch and smaller. So 3/4, 1/2 inch in the smaller pipes, just tape. You don't need to use any pipe dope, okay? But the larger pipe sizes, it's tape and dope. So you use your T-tape, but also come in with a soft set pipe dope. So you tape your joint tightly, make sure it's devoid of oil and chips and things like that. Make sure your joint is cool. If you just got done threading it, let it cool down. Don't make up a hot joint. Your pipe will shrink up and you'll have a leak. So make sure you use tape first. Put it down deep into the root of the thread, which means pulling the tape kind of tight. Get it down in the root of the thread, and then add this key tight on the leading edge of the pipe. When I say leading edge, about where the pipe dope, or about where the pipe tape is missing there, about the first 2 or 3 threads. You don't have to put it all the way up. All right, that's just a waste of material, and it gets messy. And you can see the color of it. The stuff's nasty. It's like baby poop. All right, but that's our method of sealing pipes. If you're doing 1 inch, 1 1/4 inch, 1.5 or 2 inch, tape and dope. If you're doing 3/4 and below, tape only. Well, the old 535 sure earned its keep this time. We cut and threaded an awful lot of pipe. I've had this machine since the 80s, and we just call it the mule. This thing, I don't think this thing's ever going to die. Great machine. I can't say enough good about it. I do believe they still make this machine, but that is the rigid 535, and that is my daily driver. Your choice of materials can be as simple as galvanized pipe like we did here. You can go a little more expensive with copper piping. That's always an option. Top of the heap is an aluminum powder coated material. There's many different brands. Transair is one of them. Kaiser makes another one. But they're very expensive. Also, Barzy never recommends plastic. It gets soft in the summertime when it's hot, and it's brittle when it's cold in the winter. So we never recommend plastic piping for your airline system. Thanks for watching, everybody. See you on the next one.